All right, guys, need to have your review sheets out. We're going over it today and tomorrow. Your test is Thursday, Friday.
Some of those things gonna be here Friday. We got wait.
Okay, we'll get it made up, scheduled. Now, the first thing we're looking at is problems 1 through 6. 1 through 6. Tell whether x and y show a direct inverse variation or neither. Now, direct variation. All right, guys, focus in. Direct variation comes in a few forms. Y is equal to a times x. Or we can say that x is equal to a times 1. Really the same equation. A is just going to be represented by a number. A is representing a number. Now there are two other ways that we could have this equation. Y over x is equal to a, or x over y is equal to a. These are the four main ways we can have this here. Because really switching or flipping the x and y, having y on top or x on top, really doesn't make a big difference. It just takes whatever the value of a is and flips it. So if y over x is equal to 4, x over y is going to equal 1/4. Yes. Our other variation is inverse. And the main equation we used for this here was y equals a over x. So if the equation comes in this form, we have inverse. Well, we could also say that x is equal to a over y, or our x times y is equal to a. So when the variables are on the same side, they're being multiplied together. Unlike direct, we don't have two different versions of it because x times y and y times x are the exact same thing, where x over y, y over x are a little bit different. So, if we look at number 1, 8y equals x. Is this direct, inverse, or neither?
Inverse.
So we can match it up. X equals a times y. A in this case is 8, so this would be direct. Number 2, x times y equals 1/5 would be inverse. Number 3, 6x plus 4y equals 7. Neither. One of the big giveaways is that we have addition or subtraction. If we have addition or subtraction, it's going to be neither. The only other case that we could have neither is that we only have one variable. Because for any of these here, we're going to need two variables. We're going to need an x and a y. For any of these here. So if we had just y equals 7, that's neither. We have to have two variables. 6 over x equals y would be inverse. Guys. Number 5, x times y equals 47 over 2. Inverse. All right. Number 6. Neither. And again, when you're looking at these here to determine direct, inverse, or neither, I'd just be matching them up to the general forms and see which one does it match up to. Does it match up to one of our direct or inverse? Also, you can look where the variables are at. If the variables are on opposite sides of the equal sign and they're both in the numerator, it's going to be direct. If one's on top, one's on bottom, on opposite sides of the equal sign, it's going to be inverse. If they're on the same side and being multiplied, it's inverse. If they're on the same side and being divided, it's direct. We have to have how many variables? 2. And we cannot have addition or subtraction. Questions on 1 through 6? All right.
I remember how to do this. It's like you have the time set by a certain one.
7 through 9 are not going to show up. Because you'd either multiply them together and see if you get a constant amount, or divide them and get a constant
And now
amount.
for other parts.
So the next set, 10 through 14, 10 through 13. Guys, focus, focus, in, focus. 7, 8, 9 is not on the test. 10 through 13, they want us to simplify. What we're going to be doing is simplifying. Now, when we simplify rational expressions, the first thing we need to do is factor the top and bottom of the fraction as far as possible. So we look at this first one here, 2x squared over 3x squared minus 4x. Factors of 2x squared are factoring 2x squared. Well, we can't because there's only one term, so it stays the same. So now we need to factor the 3x squared minus 4x. And what we should be looking for first is a greatest common factor. Is there a term that goes into both 3x squared and 4x? X. Because x is in common with 3x squared and 4x. Now 3 and 4 don't share a common factor, but if we factor the x out of 3x squared, we get 3x. And if we factor the x out of 4x, we're left with 4. Now 3x squared, or 3x minus 4 is as simplified as it gets. There's no other greatest common factor, and the degree is 1. Because x is now just to the first power. The degree is 1. That's as simplified as it gets. Now that we have it factored, we need to see, is there anything in common on top and bottom of this fraction? Well, we have the x and x. So one of the x's on top and bottom will simplify. So on top, it's going to go from 2x squared to 2x. The x on bottom will simplify out completely, leaving us with just our 3x minus 4. And that's as simplified as it gets. All the simplifying problems on the test, something will simplify on top and bottom every single time. Yes, sir. Yes. There's not going to be one on the test that just is simplified already. Something will simplify. Questions on 10 before we look at 11? So we need to factor either the top or the bottom of the fraction first. We're not going to focus too much on the restrictions. I mean, the restrictions for number 10 would be x cannot be 0 or 4/3. I did, I think, put those on the answer sheet, but I'm not going to ask for them on the test. Not that they add any difficulty to it, it just takes time. I'd rather you focus on other parts than just finding the restrictions. Does that answer your question? Awesome. Now this here, we do need to factor the top and bottom of this here. Now if we look at the top, 32x squared minus 50, is there a greatest common factor between 32x squared and 50? 2. 2 goes into both 32 and 50. So we can factor the 2 out first. If we factor 2 out of 32x squared, we get 16x squared minus 25. Now that is nice because 16x squared minus 25 is a difference of perfect squares. Because what times itself is 16? 4. So we'd have 4x and 4x. What times itself is 25? 5 and 5. So those will factor nicely. Now we still need to factor the denominator. 4x squared minus 17x plus 15. Since the third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Factors of 4x squared, well, we'll have x and x. Now our factors of 4 are 2 and 2, 1 and 4. Which one do we want to try first? Okay, 4 and 1. Factors of 15. 1 1 and 15, 3 and 5. And we can check this here. So 4x times negative 15 is going to be negative 60x. Negative 1 times x will be negative x, giving us negative 61x. Okay. So it's not quite the middle term, but we can switch the 1 and 15. 1, 15. And check this again. 4x times, well, like I just realized that's the exact same thing. 15 and 1, there we go. 4x times negative 1 would be negative 4x. Negative 15 times x would be negative 15x, giving us negative 19x. So we're a little closer, but not quite there. We can do 2 and 2. I'd try 3 and 5 first and see if that gets us to where we want. 4x times negative 3 would be negative 12x. Negative 5 times x is negative 5x. Negative 17x. Now, say you're getting stumped on especially the denominator for this here. Now, something is going to reduce. It's not going to work out that nothing matches up. So say we got stuck on factoring our 4x squared minus 17x plus 15. Well, we still have to finish factoring our 16x squared minus 25, yes? So we said it is a difference of perfect squares. So we would have plus and minus. So we said what times itself was 16x squared? 4x and 4x. What times itself is 25? So we'd have 5 and 5, yes? So if something's going to match, it's going to have to match up with either 4x plus 5 or 4x minus 5. Now we said that the denominator, because the third term is positive, the signs are the same and match the sign of the middle term. Both of them had to be minus, which means the 4x plus 5 on top, there's no way for it to match something on bottom because both signs are negative. So if something is going to match up, it's going to have to match up with the 4x minus 5. So if we get stuck with one of them, it's good to try to factor the other one out completely because it might give you a hint at what one of the ones on top or bottom, vice versa, is going to be. Since we have 4x plus 5 times 4x minus 5 on top, hopefully we have either 4x plus 5 or 4x minus 5 on bottom. Well, we do have a 4x minus 5 on top and bottom. So those will cancel, leaving us with 2 times 4x plus 5 over x minus 3. Questions on this here? All right, guys, focus in. Questions on this problem here? So most of this here and most of this test is going to be revolving around factoring. I'm not going to focus too much on 12 because we're not going to have a sum or difference of 2 cubes show up on the test. We're not have to, you won't have to actually factor a sum or difference of 2 cubes. No. So let's look at 13. X squared minus 4x minus 12 over x squared minus 4. Now we can pick which one we factor first. Which one do we want to factor first, the top or bottom? x squared minus 4. Because x squared minus 4 is indeed a difference of perfect squares. Because x squared would be x and x, 4 is 2 and 2, so we get x plus 2 and x minus 2. Now, all right guys, focus in. X squared minus 4x minus 12. So since the third term is negative on top, our factors for its signs are going to be opposite. One's going to be positive, one's going to be negative. Factors of x squared, x and x. Now the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Yes, sir. Yes. 2 and 6, because if something's going to match up, it's either going to match up with the x plus 2 or x minus 2. So 2 and 6 is going to be a good place to start. Where do we want to put the 2? Where do we want to put the 6? So x plus 2 times x minus 6. Now again, we can check and make sure we do get the correct middle term. X times negative 6 would be negative 6x. 2 times x would be plus 2x, giving us negative 4x, which is indeed our middle term. So these are the correct factors. And since these are the correct factors, we do have what in common? X plus 2 on top and bottom, which we can simplify out, leaving us with x minus 6 over x minus 2. Now, we don't necessarily need parentheses around them since it is a single term, but sometimes it's helpful to remember that those x minus 6 and x minus 2 are stuck together as a single term. Excuse me. Questions on this here? We ready for the next one? 14 through 25, perform the following operations. There's not going to be any monomial terms like 14. We're going to look more at 15. The top and bottoms of these fractions with our multiplication, division, addition, subtraction are going to be these monomial terms. Now, if the denominators are the same, especially with addition and subtraction, we can just add and subtract. But with multiplication, our multiplication problems, the first thing we need to do is factor each of the numerators and denominators as far as they possibly can go. So we'll start off with x squared minus 4x, our first numerator. Is there a greatest common factor between x squared and 4x? X. And it's always going to be good to start off with our greatest common factors, because it might make these problems a little bit nicer to work with. Now we factor the x out of x squared minus 4x. We're left with x times x minus 4. On bottom, x minus 1. Is there a greatest common factor besides 1? No. Degree is 1, so it's just going to stay x minus 1. If it had been x squared minus 1, we could have factored it to x plus 1 times x minus 1, but x minus 1 is simplified as it gets. The other term that's as simplified as it gets is one term, nothing we can do to it. So the last thing we need to factor is the x squared plus 3x minus 4. There's no greatest common factor between x squared, 3x, and 4. No. Third term is negative, so our signs are opposite, plus and minus. Factors of x squared are x and x. Factors of 4. 4 and 1, 2 and 2. 4 and 1, because if something is going to cancel out or simplify out, but we do have a polynomial term on bottom. We have the x minus 1, yes? It'd be nice if the top of one of these was x minus 1. Well, if we use the factors of 4 as 4 and 1, we can use x plus 4 times x minus 1. And we can check and make sure this is the correct set of factors. X times negative 1 is negative x. 4 times x is plus 4x, giving us a middle term of positive 3x. That actually is the middle term we wanted. And we can multiply these together. And when we multiply our factors, well, we can just put the sets of parentheses next to each other. And on bottom, we'd have 2x times x minus 1. Now, there's not a whole lot of reason to multiply through, because if something's going to simplify, we'd have to factor it back out anyways. Now, at this point here, do we have anything in common on top and bottom? X minus 1 and x minus 1. And we do have the x and x outside the parentheses. So all we have left on top is x plus 4 and x minus 4. And the only thing left on bottom is 2. If everything does cancel out on top and bottom, everything simplifies. It's going to reduce to what? 1. Anything divided by itself is 1. So if everything does simplify out, it's going to reduce to 1, not 0. Questions on this here?
Coming from me,
The critical thing to all this is factoring. Factoring, factoring, factoring. All right, guys, focus in. All right, guys, focus. Let's look at number 16, x squared plus 3x minus 4 over x squared plus 4x plus 4. Times 2x squared plus 4x over x squared minus 4x plus 3. Which one of these do we want to factor first? Bottom right. X squared minus 4x plus 3. Let me start there. There is no greatest common factor between these three terms. Third term is positive, so the signs are the same and match the sign of the middle term. So negative and negative. Factors of x squared are indeed x and x. Factors of 3 are 3 and 1, 1 and 3. And if we check this here, x times negative 1 would be negative x. Negative 3 times x would be negative 3x, giving us a middle term of negative 4x, which is the middle term we wanted. Well, with the second one, why don't we go on and finish it off? So 2x squared plus 4x, greatest common factor between those two terms, 2 and x. So we can factor 2x out of 2x squared, which gives us x, plus 2. So that second rational expression is simplified. X squared plus 4x plus 4 is our greatest common factor between these three terms. No, x squared doesn't have a number, 4 doesn't have x. So there is no greatest common factor. So factors of x squared would be x and x. Since the third term is positive, signs are the same and match the sign of the middle terms. Plus and plus. Huh? So 4, factors of 4 are what? 1 and 4 or 2 and 2. So we could try 2 and 2. Now 2 and 2 is going to work out nicely because if it is x plus 2 times x plus 2, one of those will match up with one of the ones on top. Now we can check this to make sure. X times 2 would be 2x. 2 times x would be another positive 2x, which does give us the positive 4x middle term that we wanted. x squared plus 3x minus 4. We need to factor it, yes?
Right there.
It's already, what?
Oh,
Oh,
4x plus.
yeah, it's x plus 4 and x.
Well, we factored it in problem 15.
I was looking at them before.
Yeah. So if it factors and we've done it before, we can just copy it back over.
Well,
But it's still the
X
steps.
minus 1's gonna go out. Do we take them out now?
So, questions on how we factor this here.
X minus 1's gonna go out.
Now the x minus 1 on top and bottom will cancel.
And the x plus 2.
On top and bottom will cancel. But since we only had one x plus 2 on top, it's only going to cancel with 1 on bottom. Now the denominator is going to leave us with x plus 2 times x minus 3. On top, we still have the 2x in the what? X plus
4. That's it?
Mhm. All right, guys, let's look at 17. Focus in, focus in, focus in. Now, the denominator of our second expression is going to be 1. Since there's not 1 written, we can write it as 1. Don't have to, but we can if we want. We can start off with x squared minus 16.
Oh, x forward 4.
X plus 4 and x minus 4. And we know this because x squared minus 16 is a difference of perfect squares. X and x will give us x squared. 4 and 4 would give us 16. Now we can start with the numerator of our first expression, x squared minus x minus 12. Since the third term is negative, our signs are opposite, positive and minus. X squared would be x and x. 12's factors are 1 and 12, 2 and 6. Okay, we can do 3 and 4 first. Which one's positive, which one's negative?
4 is negative and 3 is positive.
4 is negative, 3 is positive. And yes, if we did check this here, we would get a negative x middle term. Last one we need to factor is x squared plus 2x minus 8. There's no greatest common factor between these three terms. Third term's negative, so the signs are opposite. Factors of x squared are x and x. So we have 1 and 8, 2 and 4. Which one do we want to try first? Yeah, 2 and 4. Positive 4 and negative 2.
Now we're going to take
Now we multiply them together. Kind of one of our shortcuts we found is we can just connect them together because all the parentheses on top are going to squish in. And what cancels?
x plus 4. X minus 4. It's going to be x plus 3.
So on top we have x plus 3 times x minus 2. And since the denominator is simplified to 1, we can leave it as x plus 3 times x minus 2. We can write the division of 1, but we don't have to. It's understood. And again, if everything simplifies out completely, it's going to reduce to what? 1. I'm not going to focus too much on the monomials. I want to focus more on the polynomial equations. Now with division, our first step is going to be to keep, change, flip. We're going to keep the first rational expression the same. We're going to change it from division to multiplication and flip the second expression. Keep, change, flip. Again, as always, if you have questions on what a number is, especially on the test, or what it's f, or what it's saying, especially on the wording, you can't read what it's saying, ask. I will tell you, because that is indeed 13x, not bx. Yep. That should be a 13x. Yep. Now we need to factor. Which one of these do we want to factor first? Top left. X squared minus 3x minus 40. Is there a greatest common factor? No. Third term's negative, so our signs are opposite, positive and negative. Factors of x squared, x and x. Now our factors of 40. We have 1 and 40, 2 and 20, 4 and 10, 5 and 8. Yes, 8 and 5.
Yeah, 6 is going to be 4 and 5.
8's negative, 5's positive. And we can check and make sure x times negative 8 would be negative 8x. 5 times x would be positive 5x, giving us indeed the negative 3x that we wanted. Well, we can go on and finish factoring out the first one. So x squared plus 8x minus 20. Is there a greatest common factor between these three terms? No. Since the third term is negative, our signs are opposite. Factor of x squared are so 2 and 10. Which one's positive? 10's positive, 2 is negative. And if we check this here, x times negative 2 is negative 2x. 10 times x is 10x, giving us the positive 8x that we wanted. So 4 and 5 would have been a good idea, a good thing to, or a good one to try, because if it did work out, x plus 5 on top and bottom would have canceled. But unfortunately, it doesn't. All right, guys, focus, focus, guys, focus. X squared plus 12x plus 20. Since the third term's positive, signs are the same and match the sign of the middle term. We have plus and plus. Factors of x squared are x and x. Now our factors of 20 are 1 and 20, 2 and 10, 4 and 5. It is indeed 2 and 10. Because now we do have an x plus 10 on top and bottom that will cancel. We'll have to see about the other one, but we do have one for sure. So x squared plus 13x plus 40. Third term's positive, so signs are the same. Match the sign of middle term, plus and plus. Factors of x squared are x and x. Factors of 40 that we want are 8 and 5, 5 and 8. Because 5 plus 8 is indeed 13. Questions on how we factored any of these here? Since we have them factored, we can multiply them together. What's in common on top and bottom? X plus 5 and x plus 5. X plus 10 and x plus 10. Leaving us with x minus 8 times x plus 2 over x plus 2 times, or not x plus 2, x minus 2 over x plus 8. And that's it. 146. Now this is as simplified as it gets. We can't factor out a negative from one of these and get something to line up because both terms are not opposite. Because if we looked at the x minus 8 and x plus 8, well, yes, the 8's signs are opposite, but the x's signs are the same. Because if one of them, let's say on top, it had been negative x minus 8, over x plus 8. Both signs are opposite, and if we factor that negative out, it would change the top one to x plus 8 and would simplify. But here,
So they're going to be ones like 18.
no, they're going to be more like 19. We're going to have multiple terms. Now, there could be some that where there's one of the 4 spots has a single term, but not all 4. Because on the previous one where we had just 2x on bottom, that's fine. It's not going to be one where we just have all 4. All right. Let's look at number 20. So this time we're looking at addition, subtraction. For us to add or subtract, the denominators have to be the same. They have to be the exact same. So if we look at number 20, are the denominators the same? So since the denominators are the same, we can subtract the numerators. And especially if there's more than one term in either the top or bottom, especially with subtraction, we'd normally put parentheses. Here, we don't necessarily need them because one term, one term. We're saying 4x minus 1. Now, before we can say that this is done, is the numerator or denominator factorable? X squared. So 4x squared minus 1 is a difference of perfect squares. So 4x squared would be 2x and 2x. Now what times itself is 1? 1. So it'd be 2x plus 1 times 2x minus 1 over 2x minus 1 over 2x minus 1 would cancel. Giving us 2x plus 1.
Really quick one, while we're not in the middle of the problem. Tell me again why this sometimes works.
Because the top is parity, those two sides are switched. So you need to break that parity apart. So if you rotate the corners, because where you keep the one the same and flip the other 3, line one of the other ones up and do it that way. I'll explain here in a little bit. So questions on number 20. We'll stop there. We'll pick up 21 tomorrow.